Recording in progress.
Yep, comes on everyone. So last thing we did was this. Great. So let's go ahead. Now, dimensional analysis, right, is also useful to find the relation between different quantities. Dimensional. Meaning, example, think of like this. Let's say you're doing an experiment. Let's say you're doing a simple pendulum experiment. So we have a pendulum. The m is the mass of the pendulum. L is the length of the string. Gravity is g. So when you disturbed it and this thing started oscillating, you want to find out what is the relation between the time taken for one oscillation, the length, mass, and gravity. Now tell me one thing, when you see this, don't you get a feeling like if the length is more, it should take more time to oscillate? If the mass is more, maybe it should come down much faster. You're getting it? So maybe, we don't know, we are getting a feeling maybe this will depend on mass, length, and gravity, but we don't know exactly how they are related to each other. You're getting it? So let's say you do an experiment. Sometimes you'll see the experiment and you feel like, okay, this is depending on length, this is depending on velocity, this is depending and so and so. Let me give an example. If you go faster, if a body is going faster, does it have more energy? Makes sense. Simple thing. If a body goes faster, does it have more energy? Everyone says yes. So if I say if the body ka speed doubles, by what rate is the energy changing? Is it doubling? Now we don't know, right? So if you know the formula of mv square, then you can say, if v doubles, then energy becomes 4 times. So the point is, we can have a rough estimate, it is increasing or decreasing, but we don't know the relation exactly. So here, it's quite useful for, at least figuring out an approximate formula. Let me show you one. So we observe the time period. This is the time taken for one oscillation. Depends on length, mass, and acceleration due to gravity. Now, we know it depends, but exactly how we don't know. So this is how we start. So this time is proportional to L power X, M power Y, and G power Z. So in the LHS, we have M0, L0, T power 1. This is L power X, M power Y. This is LT minus 2 to the power of Z. So this would be M power Y, L power X plus Z, and T power minus 2Z. When you compare, you can clearly see Y is 0, X plus Z is 0, and minus 2Z is equal to 1. So Z is minus half, X is equal to half. So from here we can clearly see the time period t is depending on L power half and G power minus half. So we are getting t is proportional to root over L by G, independent of mass. So we thought it will depend on mass, but end of the day we figured out it is actually not depending on mass. So here the time period depends on 2 pi, meaning a root over L by G. This much we know. So in the beginning we had a feeling if the length is more, it will take more time, but we didn't know exactly how. So it is actually root L. Making sense? So something, this is how I'm saying, when you have an experiment, you can figure out the relation between them approximately using dimensional analysis. But it has its own drawbacks. This thing does not give you the constants. It does not work for certain kind of formulas. Let me show you that. But have a look at this. Next thing. So the drawbacks is the first one, this does not give you the constants. If you look at the actual formula, the time period is 2 pi root over L by G. We cannot find that constant. Second, if the formula is in this form, S is equal to ut plus half at square. So if the formula is made of, sum or a subtraction of two terms, we can't use this formula again. You won't get the two terms. If your PV is equal to nRT, now again, if formula contains more than 3 dimensions, in this thing, if you see, you have mass, length, time, Kelvin, mole, you have all 5. Again, we can't. It doesn't work. You will get insufficient equations. You'll have 5 variables, but you'll get only 3 equations. It becomes very complex to solve. Actually, we won't get enough equation to solve. We will get incomplete answers. We'll just write it doesn't work. So this thing has its advantages, but also it has disadvantages. Clear? Now, if you think about this thing, right, this question has quite similarities to this thing. Let me show you one more. You guys can try. Sixth one. So you have a physical situation here. This is going with speed v, velocity. This is a water jet. Where is the density? Here is the area of cross section. And this is a wall. So water jet hits the wall and stops. find the relation between the force on the wall. So when this thing hits the wall, there's a force. Let's call it symbol F and rho AB. See, one thing is clear. We know if the area is more, there'll be more force. If velocity is more, there is more force. There'll be some kind of relation between them. Now look at this thing. The same question, right? You could have asked in another way. If rho, A, V are taken as fundamental quantities, meaning for both of them the solution is same. Find force in terms of rho AB. Find dimensions of rho force. This question we did last time, remember? So for both the questions, the answer is same. You have a same solution for both the questions. Rho AVs. Where D1, A1, V1, yep. Idea is the same. So we take the force is proportional to rho power x, A power y, and V power z. So this is M, L, T minus 2. Proportional to density's mass by volume, so ml minus 3. Area is L square x. This is LT minus 1z. M power x, L power minus 3x. Sorry, this is y. 2y plus z, and this is t power minus z. See, this thing looks similar to the fundamental things. So we get x is equal to 1 minus 3x plus 2y plus z is 1, and z is again 1. Substitute here. You end up with minus 3 plus 2y plus 1. No, z is 2 actually. Plus 2. So y is equal to 1. So there. So we get f is proportional to rho a v square. And luckily here, the actual formula is also rho a v square. So when you hit a water jet to a wall, right, it exerts a pretty high force. I don't know whether you heard about this thing. Ever heard the term called water cutting? You can use actually water to cut even metal. So if you look at this thing, if you divide force by area, we get pressure, which is rho v square. So for water, let's say rho is 1000. And if you take 100 meter per second square or even 50 meter per second, that value turns out to be around 10 power 7, which is 100 times atmosphere pressure. So if you can make water into a thin jet of water, right, and you hit something, you can literally cut it. You put your hand goes off. So how does this look like? It looks like this. That is a steel lock, and that's a water jet. You can clearly see. Just slices of, like, knife going through a butter. So it's called water cutting. It has advantages. Meaning normally if you try to cut with this regular welding or any solid surface, right, the edges will not be smooth. The edges will become rough actually. But when you do cut with the water, you get a pretty smooth finish. So it is especially used for, high-end items, like, when you want to have very high precision, we can use this. So you can make the water jet thinner the stream, more the easier the slice will be. Now in that water jet, just imagine your finger going through that. Gone. You will have one finger less. Next thing. So this is one way. Next thing, dimensional analysis, right? So this is one use of it. We can figure out the formulas for different things. Next thing, dimensional analysis is useful for conversion of units. For example, let me show you an example. That's the best thing. Let's say in a new system, someone has taken 5 kgs of mass, is taken a standard unit. Meaning, why should you take only 1 kg every time? Someone must have chosen 5 kg as the standard mass. 10 meter is taken as standard for length. 20 seconds is taken as standard for time. Meaning, what do you mean by this exactly? Think about it. Let's say I'm a real estate agent, okay? I sell apartments and stuff. Now, when you come to me and you ask me, like, अरे यार, ये घर का area कितना है? I will say, sir, it is 1200. Then he'll ask, ये घर का कितना है? ये 800. ये kitchen का size कितना है? 700. No, when I just put this number, right, you know what I'm talking about, right? I'm talking in what? 1200 square feet, 1600 square feet. It is understood. So for a real estate agent, the unit would be like square feet. But imagine you're coming to me and I'm trying to sell you agricultural land. And when I try to sell you the land, what will I say? Will I say 1000 square feet of land is there? I will say half acre, 1 acre, 1.5 acre is there, isn't it? Can you see the difference? So even in a real estate, right, the guy who's selling agricultural land, he will say, sir, यहाँ पे 3 hai. So for him, the unit of measurement is an acre. But a real estate agent selling apartments, right, he will say, sir, there is 1200. He's talking in terms of square feet. So the unit of measurement is square feet. You're getting it? So people prefer to have different kind of measurements. Now, if you see 1 acre, I think is roughly around 40,500 square feet. Acre is pretty big. Getting it? So someone has taken some new standard of units. Getting it? So we want to let's find the relation between force in new units and old units. Let me show you how to do this thing. So listen carefully. I'll show you one and I'll ask you one more. So in the new units, let's call this thing m dash, right, is 5 times m, because you said 5 kgs is a standard for this. So this m dash is your new m. L dash is, I took 10 meters, right? So 10L, and T dash is 20T. MLT is your regular units. M dash, L dash, T dash are your new units. So the new force, let's see, the dimensions will still remain same. This would be M dash, L dash, T dash minus 2, isn't it? MLT minus 2. But M dash ka place mein you have 5M now, L dash ka place mein you have 10L, and T dash ka place mein we have 20T ka square. So that would be 50 by 400 MLT minus 2. So the new units of force would be 1/8 of this old unit of force. So example, let's say if you say force is 10 Newton, the meaning of this is, look at the meaning of this. The new Newton, so 1 Newton dash will be 1/8 of the old Newton force. So basically 1 Newton is 8 times Newton dash. So when you substitute this here, this is 10 into 8 N dash. So the relation between the old units and this thing, right? So the force is represented in terms of new units, mein 80 Newton dash. Is this making sense? So think of like, I'll give you an example. You measure everything in meters, okay? You measure everything in meters. I measure everything in centimeters. Okay? You come and tell me, sir, here, take 2 units. What will I say? Oh, you gave me 200 units. Is it making sense? Because for you, the unit is meters. I measure everything in centimeters. You come and tell me, sir, take this half meter. I will say, oh, you gave me 50 units. Is it making sense? I'll come and say, here, take your 30 centimeters. You will say, okay, you gave me 1/3 of a unit. You get in the difference how we both are talking? Your unit of measurement and my unit of measurement are different, because I talk everything in centimeters and you want to talk everything in meters. So this way we can have a conversion between your and my unit. So I will say 1 unit of yours is 100 units of mine. Does it make sense? So we have a conversion factor. So this is an example. See, so in the old units, if the force is 10 newtons, in the new units it is 80 times Newton dash. So we have something like this in SI and CGS units. If you see 1 Newton is 10 power 5 dynes. So Newton is a unit in SI, dyne is a unit in CGS system. CGS may they use centimeter, gram, and second. Clear? All got this? So let me show you one more like this. You guys give me the answer. Turn in the page. Let's say in a new system. 2 meter is standard for length. 3 kg is standard for mass. 5 seconds is standard for time. If power is 10 watts, find the power in new watts. But in real life, what we do now, we don't call it watt dash. We'll give a new term like dyne, erg, and something like that. But okay. So I'll simply call it the new units is watt dash. Is my question clear? So this is how you convert 1 units to another. Give it a try. 1250, that is 625 by 6. We have two different answers. We have 625 by 6 and 625 by 9. One of you is wrong. I'm getting a feeling that by 9 is wrong. Oh, 300. Nahi re. 625 by 6. We have two 625 by 6. Try. I'll give you a minute more. Figure it out. See where you went wrong. Be careful at 2 meter for length. Maybe you took 2 kg for mass. So, yeah, 625 by 6. I think multiple people are getting that. Maybe right. Let's see. Let's see. So m dash is 3m because 3 kgs you are taken. L dash is 2L and T dash is 5T. 5 seconds of the time. Okay. Then power is. So the new power ka dimensions is m dash L dash square T dash minus 3. So substitute here 3m 2L ka square 5T ka cube. That would be 3 into 4 by 125 ml square T minus 3. That is 12 by 125 watts. The old power. That means indirectly you're telling you 1 watt dash is 12 by 125 watts. So you're saying power is 10 watt. So that is 10 into 125 by 12. That is 625 by 6 watt dash. Check your calculations. So in the new dimensions which you have taken, right, the old power, which is 125 by 12, 1 watt of 12 by 125 will be the new units of power. All clear with this? Let me give you one more. Any doubts on this? Let's see one more. Turn the page. All clear, na? Janil, Arya, Arnav, got the thing? Daksha, got your mistake? Niharika, got this? Ishana, Devansh, Pratik, Nikhil. Great. Next thing. In a new system, alpha kgs is taken as standard for mass. Beta meters is taken as standard for length. And gamma seconds is taken as standard for time. Find relation between new and old units for energy. Meaning what is 1 new unit of energy in terms of the old units of energy. So generally, energy units are joules. So I could have given that. Answer will come in terms of alpha, beta, gamma. Hmm. Let's say. So the new mass will be alpha m. The new length will be beta L. The new time will be gamma T. So the energy, the old new one, the dimensions would be m dash L dash square T dash minus 2. So alpha m beta square L square by gamma square T square. So alpha beta square gamma T square would be ml square T minus 2. That is your old units. Example, let's say if you tell me energy is 10 joules, so indirectly you're saying 1 joule dash is alpha beta square gamma square joule. So substitute here. So this will be 10 into gamma square by alpha beta square joule dash. That's the relation. I hope everyone is getting this conversion. So if you see units and dimensions, right, these are the four models. The first one is what? Finding the dimensions is one. Second thing is taking alternate fundamental quantities. Then we had dimensional analysis. Then we had units conversion. And then we had that formula thing also. If a situation is given, like water jet wala problem, you can find the relation between the equations. So these are the main models in this dimensional stuff. Not tough, easy one, but yeah, you should know how to handle these things. Clear? That is the first part, units and dimensions. The second part is errors. So between that, there is one more small part called significant figures. Significant figures or SF. So what are the significant figures? So these are the digits in the measurement which are reliable. So people, right, they initially they had a problem because people were not using same units. I'm studying somewhere in, let's say, India. I'm measuring everything in kgs. You are measuring everything in Europe in foot and pound. Things are messed up. Our research papers are a mess. Then we said, yeah, no, both have to do the same thing. So we started following SI units. Then people face the second problem. When you report it in your research paper, the length is 2 centimeters. I'm not sure what is the accuracy of that measurement. Are you really saying 2 centimeters? What kind of scale did you use? For example, let's say if you use your kitchen ka scale, kitchen ka weighing scale hota hai na, chota wala. Ever seen that? That it looks like small thing. So let's say some pharma company, right, is making medicines using kitchen ka scale, right? So when you put something on the kitchen ka scale, let's say it shows 2 grams. The problem with the kitchen ka scale is it can show 1 gram, 2 gram, 3 gram. That's the minimum, right? That means if the measurement is 1.6 grams, also it will show 2 grams only because there's no reading only. Or even if it is 2.4 grams, it will still show 2 grams only. You need to understand how machines or how we are designed is. For example, see, if you have a scale like this, and let's say this is 2 and this is 3. If you got a reading somewhere here, what do you think the machine will show you? It will not say this is looking like 2.2 something, kuch nahi. It will say 2. If the reading is here, it will say 3. You're getting how machines work? They know 2 and 3 only. They don't know anything in the middle. If you want anything in the middle, then you have to define more divisions here. If you don't define any divisions here, the scale will simply say the machine will show 2 or 3. So abhi iska problem ye hai, that means anything from 2.5 to 1.5, any reading between this, the machine will show 2 only. Does it make sense? The problem with the machines is any reading between 1.0 to 2.5 will show 2 only. And now you're making medicines. Let's say you're supposed to use actually 2 grams, right? But you actually kept 2.49 grams and the machine showed 2. So there's a drug overdose of almost like how much is that? 25% overdose is ho gaya. You're getting the problem there? The problem is now you can't use such a scale in pharma companies. So we need more precision. So if you ever open a pharma company, right, in ingredients, if you want to say exactly 2 grams, you know what they will say? 2.00 grams. They are very precise. So we will see what is the significant figure. So the second problem people faced was people are using different scales, different instruments, and they started messing up the whole readings. We don't know whether someone actually used a good instrument or a bad instrument. So this significant figures will help you to figure that out. So let's see how it works. So if you have something like this, a scale, let's say this is 6 and this is 7. And let's say a reading comes somewhere here. Now, if you look at this, let's say this thing also has smaller divisions. Now, the problem here is if I tell you to look at this reading, I'm sure it is 6. I'm sure it is 4. But that last digit, right? I'm not sure exactly what it is. It gives you a feeling it looks like 3. Some people will say 4. We don't know. So out of all, the 6 is the most reliable digit. Means you're pretty sure about this. Whereas this 3 in the end is the least reliable digit, meaning that is the one with the highest chance of having an error. Getting it? So we say for this instrument, for this reading, this thing has 3 significant figures. So up to at least 3 digits, you have some idea there. I agree, the last one is not good, but still. So for in this case, we have significant figures are 3. Now there's one thing about this. Significant figures, right? They work well. They're supposed to be used for accurate instruments. So when the instruments you're using are good and you use significant figures, they work well. But if you start using messed up instruments, you will get pretty weird answers. For measurements done with accurate instruments. Now let's see some rules here. There are certain rules which you have to follow. Meaning, just think about it. Let's say you're designing a door. Okay? Now, if you're designing a door for your house, if the person, let's say we have a door here and that carpenter, right, makes a door and brings it, and let's say there's a gap of 1 centimeter here. Are you okay with it? You're not okay with it. You're so strict, Vihan. The carpenter will leave you and will say, "Tu khud door bana le." Right? If you have a door, he makes a door, and let's say there's a small 1 centimeter gap here, you're okay with it. देखो अभी भी आपका डोर पे गैप होगा, 1 इंच का गैप होगा नीचे. You're okay with it. But imagine this is the same door you're using for a submarine. Are you still okay with it? You're getting it? Now you need more precision. Same thing if you're making a door for a satellite or for an space shuttle. You're getting it's the same door, but the accuracy will depend. And when you want more accuracy, it becomes more expensive. So it's always like how much accuracy you want. If you want very high accuracy, you need to spend more money. But how much accuracy you want. For example, see, if you're making a door for a space shuttle, right, the accepted error or that, see, you can't do anything. There'll be always a small gap. Whenever you weld two joints, there'll be always a small gap. So what you can accept is the error. They will say the gap should be in the range of 10 power minus 6 meters. When we are talking about an error after like 5 zeros or something. You're getting it? Now the problem with this thing, I'll tell you, see, if you use a regular blade to cut it, आपका blade का thickness will be more than this, isn't it? If you take a blade or anything to cut it, the thickness will be more than this. That means that gap will be definitely more than the error. So if you want such a kind of small thickness, we can't use physical blades, we have to use lasers. You can make a laser which is much thinner and that can be used to cut it. You're getting the problem? It becomes more expensive. So your carpenter who is using, he will use a blade. If you see that blade ka thin, right, thickness, it will be maybe 0.01 mm or 0.1 mm. And that much error is acceptable. So instruments, right, you have a special labs only for that. When you want accuracy, it is a different game. So let's see what are the rules for Signant figures. The first one, all non-zero digits that is 1 to 9 are counted as significant. Second, zeros before the first non-zero digit are not counted. Example, the best thing about this thing, examples only make sense. Statements, right, you won't get much of an idea. So listen to the examples. And if you feel like there's some other example, you can ask me also. So 0, 2, 3. Now see, that 0 in the front is useless. It is just there for the namesake. So this thing has only 2 SFs. So if you say something like 0.631, now this can be written as 6.31 into 10 power minus 2. So the first 0 is not actually helping you for anything. Suppose if you have 0.0123, this is 1.23 into 10 power minus 4 or 10 power minus 3. So even if you have a decimal in the front, if you see these zeros are not counted, they don't mean anything. They're not useful. But let's say if you have something like 001, 4, 04001, something like that. Now these zeros are counted because the zeros between them, they make sense. Again, these zeros are not counted. So if you have zeros between non-zero digits, they are counted because this can be written as 104001. That will be 6 SF. You're getting this? So zeros between the non-zero digits are counted. So this is the statement, the zeros before the first non-zero digit. So this 6 is the first non-zero digit. 1 is the first non-zero digit. Before that, all zeros are useless. They don't really help you in any accuracy or any measurement. Zeros between non-zero digits are counted. Have a look at these two. There are more rules, but this is the first thing. 10 power minus 1. Yeah, that is 10 power minus 1. I wrote wrong. Any doubts on this page? Clear? The third rule, this is the important one. Zeros after the decimal are important. Meaning, if you say 2.30, that zero is counted. This thing has 3SF. If you say 3.002, those zeros actually are helpful, 4SF. If you say 40.000, all zeros are counted. That is 5SF. Now, be careful here. But if you say 500, now see, there is no decimal here. This can be written as 5 into 10 square. These zeros are not counted because there's no decimal. I'll tell you why. Getting this thing has only one SF. But if you tell me, no, sir, I want to count those zeros also, then you should have reported the answer as 5.00 into 10 square. Then I will say it as 2SF. So people came up with some rules actually. They said they started having a problem with this. Let me show you what happened exactly. So look at this example. If you say 6,000 centimeters, this can be written as 6 into 10 power 3 centimeter. This has one SF. But if you say 6.000 into 10 power 3 centimeter, even though they look the same, they're not same. This is 3SF. It's 4SF. So why? Because see, both look like 500, but both are not the same things actually. Let me show you why. I'll come back to this page. So listen carefully here. What was happening was, imagine you are doing some experiment and you reported the answer as 500. So like I said, we don't know what kind of scale you are using. So this is what we'll assume. If you come and tell me, sir, length is 500 centimeters, this is what I will assume. I will assume you're using a scale, a very bad scale, whose divisions are 500, 600, 400. Matlab, your scale is not accurate at all. Each division is a distance of 100 centimeters. That means, just like I told you how machines detect anything, this can be anywhere. This reading can be anywhere between 450 to 550 centimeters, isn't it? Think about it. Suppose if you get a reading here, what will the machine show? 500. If you get the reading here, what will the machine show? 500, isn't it? Because it knows only 400, 500, 600. It doesn't know anything in the middle. Are you getting my point? So if you just tell me 500, I will assume you used a very bad scale, which is giving only 100 centimeters divisions. Then you come and tell me, no, sir, that is not my intention. I have a better scale. Then you come and tell me my scale is 5.0 into 10 square centimeters. Then you know what I will assume? Okay, you have 5.0. That means your scale, 500. That means your scale has 510 and 490. Means your scale is now having 10 centimeters divisions. You're making sense? That means this can be anywhere between 495 to 505. Meaning any reading between these guys, you will report as 500 only to me. This is also a bad scale. Are you getting the catch? Then you tell me, no, I actually am using a very good scale. Let's say I'm actually want 500 only. Then come and tell me 5.00 into 10 square. So the moment you write the answer as 5.00, see, look at this thing. Without the other person knowing what kind of scale you used, tell me one thing, do you want to write like this every time? 500 centimeters, I used a scale which has divisions up to 1 millimeter. Will you write that every time beside? So when you write like this, I will assume this is the thing you're using. So people said, here, let's have a common convention. Just looking at the decimal, the other person should be able to tell what kind of scale did you use. So when you say 5.00 into 10 square, I will assume you used a scale which is 500 and the next division is 501. Is that making sense? Meaning this reading can be anywhere between 499.5 to 500.5. Now I'm more assured. So if you're making some kind of medicines in a pharma company, and when you come and tell me 2.00 gram, I know the error is, it could be anywhere between 199.5 to 200.5, meaning 1.95 to 2.05. Now, I'm okay with this much small error. There's no overdosage. But when you come and tell me 2 grams, I get scared. It could be 1.5 or 2.5. Are you getting the catch? If you come and tell me I have even a better scale, then you'll say 5.000 into 10 square centimeters. Means you must be using a pretty good one. Your scale is so good, the next division is actually 500.1. Meaning this reading will have an error anywhere between a 499 point, how much is that? 95 to 500 and 050. 499.95 to 500.05. Make sense? So when you put 4 decimals like this and tell me, I know what kind of scale you used. Is this making sense, everyone? That is the reason 6000 and 6.00 into 10 power 3 are not same. Even though both look like 6000, this reading, this thing is actually between 5500 and 6500. It could be anywhere between that, and the machine showed 6000. I hope everyone is getting this. This might look silly, but when you're using pretty precise instruments, right, things get really messed up. Happens a lot, especially with weather department. In weather department, what happens, right? You have to put some variables like temperature, humidity, and all. And in that, they put up to 3 decimals, and the machine rounds them off. So if someone puts 6.37 and someone puts 6.36, that 1 decimal ka rounding off, right? Nothing will happen today, nothing will happen tomorrow. But when you predict the weather after a month, that one small variable will mess up the whole results. That one small error is sufficient to, it creates a kind of a chain reaction. Clear with this? I hope everyone is getting why 6000 and 6.00 are completely different. Any doubts on this example, please ask me. So the reason why we had to do this is because you did an experiment, I did an experiment. Now I don't know what kind of instruments you're using. So if you come and tell me 500, I'll tell you, boss, what are you using? Use better scales. Matlab, I don't even know what scale you used. You're getting my point? I'll say like what kind of instruments you're using. So I'll tell you, if it's a pharma company, right, every unit that you measure will be something like this, 2 to 3 decimals. But let's say if you go to a grocery store, they're okay with that. Matlab, ever seen a grocery store ka thing? They have only 2 decimals. वो भी बहुत ज़्यादा है actually. So 1 decimal is fine. Clear with this? There's a 4th rule. I can write it here only. Constants of infinite SF. Example, if you tell me number 3, for example, how many apples are there? 3 apples are there. You're pretty sure. 3.0000 means you're sure up to the last digit. It has infinite SF. There is no 3.01 apple. There is no 2.91 apple. It is 3 apples. But same thing, if you come and tell me length is 3 centimeters, so measurements have errors. So this thing has 1 SF. This is a measurement. So how do you know whether you're dealing with a number or a measurement? Look at the units. If you say 3 centimeter, I know it's a measurement. If you don't put any unit, I will think it's a number. Clear with the rules? Let me give you some problems. You tell me what is the answer for each SF. Then that is a better way to get things cleared. But any doubts in the rules, please ask me.
Sir,
Vinod.
Sir, in that part, 5.00 into 10 to the power of 2, in 5 wale page pe, previous page. It would
Sorry,
be
3 SF. 3 SF. I wrote wrong. Yeah, 3SF. All clear? Let's see a question. I hope you're getting it. Like why this is important. It might feel like yeah, ये क्या है, but see, one research paper कुछ नहीं होगा. But every year, thousands of research papers are being published, and everyone gets confused like what instruments are using. You can't always call the person who did the experiment and ask him, right? You might not have the contact, or maybe that experiment was done 40 years back and that guy is dead already. You don't have a landline to heaven or hell, and you can't call them. WhatsApp bhi nahi hai. That doesn't work. So all these things that people actually faced problems, when they're trying to compare papers and they got pissed off and said, yeah, everyone used same units. Now, seriously, uh, because of not only exactly because of units, people say, there are many research papers and many things are done, but because people don't use same standards and all, the technology has not progressed the way it should have been. Meaning there's an estimate. If every technology has progressed the way it is supposed to be, right? Shakespeare would have written his novels or poems, in a laptop. Matlab, imagine. I think Shakespeare is around 1600, 400 years. So we got a laptop after 400 years. That guy would have written his whatever poems and everything. He must have published on Instagram and novels and everything in that time. But many technologies have been lost. People did research. Maybe there is a wipeout. Maybe people didn't have, they didn't write on proper papers and stuff. People always talk about cave paintings, right? Ever heard about it? Cave paintings, this old caveman did. If you think about it logically, most people must have painted them on trees also, which is more easy to paint on trees, isn't it? Than actually stone. But all those trees must have been dead. That means the guy who painted on the stone, right? There might be 100 times more paintings and more talented people who must have done on trees, but those trees didn't survive. Luckily, we just got to see the cave paintings and we think, yes, smart hai. But we don't realize how many people must have missed it out. So standardization, when you have a certain standardization, it becomes easy to communicate your knowledge to future generations. So I'll just give you some things you can manually do it. Don't need to answer. And the end, I'll show you the answers. You can verify whether you're right or wrong.
Sir, what do we have to do in this question?
Tell me the number in terms of alphabets. Meaning 3.2 should say it is 3 THRE point. Find number of significant figures, रे. अभी क्या कर रहे हैं? Last half an hour से we are doing SF. What else will you do? अभी क्वेश्चन लिखा ही नहीं मैंने. चलो, write down. Find the number of significant figures. That's what I'm asking. चल लिख लेता हूँ यहाँ पे. When we used to go to movies, when we were kids, my sister used to be like this only. She used to wake up in the middle of the movie and ask what is happening. I used to say sleep. So जाओ वापस. So now, for 1 hour you slept in the movie and then you wake up and are asking who is the hero and who is the villain. कुछ समझ में नहीं आया. I used to tell her, I'll wake you up in the break. Let's eat samosa and fruity. You go back to sleep. You used to sleep again. I used to wake up her in the break. Used to take her out for fruity because I also used to get half of it. And then it was like that. 0.123. You can have negative numbers also. There, just give me the answers. Finish off 30 seconds, then I'll show you the answers. You can check. See, this thing has 2SF, 4, this thing has 1 because I can write this as 4 into 10 power 4 centimeters. All those zeros on the corner are useless. Getting it? If you want me to count those zeros, put a decimal. You should write 4.000 into it, then I will count it as. This thing has only 1 SF. You're getting, this is a rule we made so that people don't get confused between 40,000 and 4.00 this thing. That tells you the scale. This thing is what? These zeros are not counted. I can actually write this thing as 1.0020 10 power minus 3. This thing has 5 SF. This thing has infinite SF. This is a number. There are no units. That is not 23 centimeters. This is a number. This thing is 3 SF. This thing is 4, 4, 5, 6. All got it? Any doubts? Straightforward, easy stuff, but you should know the rules. Right? Next thing. That is one thing. Next thing is rounding off. This is very important. So like I said, when you put a value in a machine, how do you want it to, calculate? Let's say you give to a machine 6.234 centimeters, but the machine can only count up to 2 decimals. So rounding off. Now we have some rules there. So if the number, again, let me show you example. That's a better way to understand. Definitions really, that last number is greater than 5, then the digit before increases by 1. Example, let's say 7.36, and someone tells you round off this to 2 digits. So when you say round off to 2 digits, 7.36, look at the third digit. You want to see the second digit, the round, so you see the third digit. This is greater than 5. So the number before that, that is 3, will become greater than 1. So this should be rounded off to 7.4. Got the logic? Suppose if I have one more example, say 8.679612. Now, if I ask you round off to 2 digits, 4 digits, 1 digit, what do you guys think is the answer? I'll show you for 2 digits. See, you want 2 digits, no? 8.679612. If you want to 2 digits, then look at the third digit. This is greater than 5. So this guy will be 8.7. So whichever digits you want to round it off, look at the next digit. Greater than 5, increase by 1. What about 4 and 1? Try. I'll give you 10-20 seconds. Look at this thing. You want to see the fourth digit? 8.6 and then 612. Now this is an interesting one. See, you look at the fifth digit. That guy is greater than 5. So you have to add one number before. But if you add number to 9, it will become 10. So that will be carry forward there. So this will become 8.680. Is that making sense? That's 6. You have to put 1 for 9. But when you put 9 plus 1, it will become 10. So that 1 will go forward. That will become 8.680. This is interesting out of all the one digit one. So you don't care about the remaining trailing digits. You're getting it. If you say third digit, forget about 4, 5, 6, 7. Let them go to hell. Ignore them. So 8.69612. So you just look at this guy here, 6. This is 9. Clear? You want only one digit. So 8.6, 6 is greater than 5. You're done. It is 9. You can see that amount of error you're getting, right? This is what happens. So if your instrument is not proper, and if you put 8.67916 to such a good value, and the instrument is bad, it will show 9. All clear with this? Turn in the page. Same thing. If the number is less than 5, you keep it as it is. Don't do anything. Then last digit remains same. So example, if I say 8.347, something like this. So if I round off this to 2 digits, then I will look at 8.3472. I will look at the number 4 less than 5. So this is 8.3. If you round off this to 1 digit, that is 8.3472. I will just look at this 3, which is less than 5. I'll report it as 8. So look at third digit. Clear? Now, this is the rules what are given in NCERT. Now, there is one more rule. Now, this is not there in NCERT. I checked it out from some foreign research paper, foreign website where they use this. So we will use the same. But there is still, this is a little confusing actually, when I never understood what the hell is this exactly. If the digit is 5, greater fine, less than fine, but if the digit is 5, and if the number before is odd, the problem, you have to make a rule because computers won't understand. If you just leave it there, the computer will get confused. It'll send you an error code. Most people don't realize this. Most things, right? People feel like, yeah, the rules are nonsense. But think about it. Greater than 5, less than 5, you wrote it in the program. But if value 5 comes, what should a computer do? You didn't tell what to do. It will send an error message. The program will fail. So you have to take care of all contingencies. Even the rule doesn't make sense. You have to give the computer something to do. So I think from there, they made up this weird rule now. The number before is even. We do nothing. Let me show you with an example. Let's say example, we have 8.345. We have example 8.335. Now, when you look at this thing, this is 5 and this is even. So I do nothing and I'll just keep it as 8.34. This is 5 and this is odd. I will make this 8.34. Making sense? So if it is 5, this is the rule. Greater than 5, there's no confusion. Less than 5, no confusion. It makes sense also. Equal to 5, it doesn't make sense. But we don't have a way out actually. Have to make something. Huh, Puruja, you got something?
Sir, in the previous slide,
Mm-hmm.
No, sir, this one only. Sorry, sir.
Hmm.
When we round off to 2 digits,
Hmm.
so like before 4 there is 7. So if we first round it off to
We don't
5.
do that. We don't do that. And then उसमें क्या होगा ना? In that sense, you're actually compounding the errors.
Okay.
You're getting it? That 7 will give you make it 5. That 5 will make 3. So that will become 8.4. Did you see how much error increased?
Yes, sir.
So we don't do that. What you're saying now, I understood. Meaning, if that is the case, why should I leave at 7? Why don't I start from here? Getting it? That will be a compounding of error. So we don't do that. That is like, first of all, what you're doing is a mistake. So just cut off there and leave it. Na? Don't keep on compounding the mistake. It adds up. Clear, everyone? This is how we round off things. So let me give you a few questions. You do it and show me. Turn in the page. So we have something like 6.73558. Round off this to 5 digits. 4, 3, 2, 1 digit. Let's say we have 4,276. Round off to 1 digit. 6,000, let's say 5,735. Round off to 4 digits and 1 digit, 2 digits. Get them all. You got a minute. Just give it a try. Get some water and come. Let's see. 4.3, 40,000. I hope someone didn't do 43276 as 4. When you round off 43,000, it won't become 4. Let's see how to write that. You won't write like that, right? You can write that, but okay, that's not the right way to do. But still, let's say 5 digits ke liye kya karna hai? You have to look at 8. That is greater than this thing. So 6.7356. For 4 digits, look at this 5. So before that, it is a odd number. So 6.736. For 3 digits, 5. Again, the number before is odd number, 6.74. I should have made that 2 now. ठीक है. And 6.73, so 6.7 only, and this is 7. Got this? Now look at this thing. One digit, right? So you have to round off this guy. So that is 3, which is less than this. You keep it as it is. You write this is 4 into 10 power 4. Don't write 40,000, meaning 40,000 is not wrong, but write this 4 into 10 power 4. That is the right way of writing it. Clear? It won't become 4. 40,000 don't make it 4. It is still 40,000 only. What about this guy? 4 digits, meaning look at this 5. So before it is a number, so nothing happens there. You can write this thing as 5.734 into 10 power 4. 2 digits, so you can write 5.7 into 10 power 4. Clear? So just put powers and then it will be more easy for you to figure it out. Most people get confused here when they see this one digit. Isko kya karna hai? People will think 4. How can 40,000 become 4? What kind of error is that? The meaning of this is someone is using a skill so bad, it can be anywhere between 45,000 and 35,000. Something of that sort. But anyway, this thing has 5 significant figures. But if you put this value in a computer which can measure only one digit, this is what it will think. Clear, everyone? Next one. So when do you add measurements and subtract measurements? Again, what are the rules that you follow? Can I go ahead? Any doubts on this page? Clear, na, Arya? Ansh, Ahna, got this? Surya, clear so far? Great. Next thing. Addition and subtraction. The rules are pretty straightforward. So if you give me 2, 3 numbers, I'll just add them or subtract them, and then we'll round off to the same number of decimals, least number of decimals. I'll tell you what it means. While adding and subtracting, if you're adding an accurate value to an inaccurate value, the final answer can't be more accurate than the inaccurate one. Meaning the measurement should have same number of decimals as the measurement with the least number of decimals. Again, let me show an example. Let's say if you're adding 1.23 plus 3.145. First, just add them up. 1.23, 3.145. So this will be 5, 7, 3, and 4. Now, if you look at this, again, we are counting decimals. This thing has 3 decimals, meaning this thing you're using a pretty good scale. This thing has 2 decimals, decent scale, but it is not as good as that one. So when you add an accurate one with an inaccurate one, your answer will be as good as 2 decimals only. So we need to round off this to 2 decimals, not 2 digits. Round off to 2 decimals. Because the least number of decimals are 2. Means we look at this number 5, and this is odd. So this answer will report as 4.38. I hope you're getting the logic there. If I show you one more, let's say 6,000 minus, let's say 23.7. This thing is 6,000 minus 23.7. That would be 3, and that would be 9 minus 3, so 6. How much is this? 6,000 minus 23 is 5,976.3. Yeah, that looks right. Now here the catch is this thing has no decimals. So this answer is also no decimals. So round off this thing. 5976. Making sense? So when you're adding or subtracting, you're only interested in decimals. And the logic is pretty making sense also. Matlab, you used a scale with 3 decimals, used a scale with 2 decimals. When you add them, how can you make an inaccurate answer as good as 3 decimals? Clear with this? Clear? Let me show you something. You guys try this. .34 centimeters plus 2.2 centimeters. 323 centimeters plus 0.41 centimeters. 32.31 centimeters minus 0.7. 45.613 minus 4.1 plus 2.23. Let's get them all. First, we just add and subtract like normal, and the end we can see. One then accuracy decrease if we added 2 decimal with a 3 decimal. It becomes less accurate now. See, the 3 decimal is more accurate, isn't it? You're bringing a more accurate one with a less accurate. What will happen? The whole thing will be as good as the least one, isn't it? You're still not sure about the 3rd decimal, right?
Yes, sir. But if there is a 0.05 ka difference, then with a 3, it can be reduced to 0.005, right?
Meaning,
So
what you're
that much
talking?
is like for the
God, when you're
first,
adding here, you don't know what is this number here, isn't it?
yeah,
So you don't know what is this number, right? So this thing actually is a useless digit.
okay, but all right, ठीक है.
Tell me one thing. This number could have been anything from 0, 1 to 9, isn't it?
Yeah,
And then that means this, if you actually say this is 5, this thing is actually the most inaccurate one.
okay.
Making sense, no? You don't know the last digit. For the 2 decimal one, the 3rd decimal you don't know only. So here, when you added it, you took it as 0 and you added it, isn't it? Isn't that a mistake, first of all? So you can't be sure about the 3rd decimal. So don't bring it all into the picture because you don't know, eliminate it. Finish off. So have some fun getting it, because after next week, you won't get to see such happy and interesting, nice questions. I'm just teaching you addition, subtractions and stuff. So like I told you, breather chapter, matlab beech mein ek break aayega. I'm pretty sure you must have never thought in your life, and after looking at that kinematics, you must have never thought I'll teach you additions. No, but it is important. Matlab, they do ask in mains and bits these kind of questions, and people do goof up and come. Simple 4 marks. What is the first one? 7.342.2. Yeah, what is this thing? 7.342.245, 7.54. But this thing has only 1 decimal, so your answer should also have 1 decimal. So round off the 4, so 7.5.
So it would be 9.54, right?
Yes, sir.
9.54. Then 9.5. This thing is what? 323. That 0.41 anyway looks useless. I'm just writing down the answers which you guys wrote and too lazy to count. This thing is 32.31 minus 0.7. So that's 1. 13 minus 7 is 6. 31.61. And this thing has only 1 decimal. So I'll round off this to 1 decimal. 31.6, right? What are the last one? Anyone did that? 43.74. Nee, na? See, this thing has only one decimal, so your final answer should have one decimal. Now, understand one thing, exam they'll ask you like this only. You know what they'll ask? Let's say, what is the answer for the last one? Anyone got it? 39.3, 43.7. Now, when you add everything, what are you getting? Up to the 3 decimals, kya aa raha hai?
43.743.
43.743. Getting it? Exam options will be like this: 43.743, 43.74, 43.7, and 43. They'll ask like this. So they're not expecting you to add and subtract. Among all this, who has the least number of decimals? This guy, right? So your final answer should have only one decimal. So mark it. Bus. There's no need to add. Options will be given like that in the exam. Because they're not trying to test your addition subtraction knowledge. They want to know whether you know the rules or not. So round off to 1 digit, so 43.7. Is this clear, everyone? So simple. Addition subtraction where the rules are, you should have the least number of decimals in the final answer. So whatever your measurement has the least accuracy, make your final answer also the same accuracy. Clear? Any doubts on this? Next one, multiplication and division. Now in this thing, the result should have same significant figures. Now this thing is same SFR, not decimals. Same significant figures as the measurement. With the least SF. Example, if you say 2.22 into 1.1. So this is 222, 222, this will be 244. So this is 2.442. But look at this thing has 3 SF, this thing has 2 SF. So final answer should also have 2 SF. So for 2 SF, I need to round off this thing. This will be 2.4. That is how we count. You should have the same number of significant figures as the least measurement. Example, let me show you one more. If you have 442 by 2, this is 221, but this thing has 1 SF. This thing has 3 SF. So your final answer should have 1 SF. So I'll round off this to 2 into 10 square. But the same thing, if you told me 442 by 2.0, then I will write this thing as 2.2 into 10 square. If you tell me 442 by 2.00, then I'll write this thing as 2.21 into 10 square. Did you see how it changed? Because the moment you put decimals, this thing will have 2 SF. This thing has 3 SF. So in multiplication and division, the catch is the number of significant figures. Addition, subtraction, it is a number of decimals. Clear? Let me show you a question. Now let's say the length of a cube is given by 8 centimeters. Same question. Length of a cube is given by 8.0 centimeter. Same question. Length of the cube is given by 8.00 centimeter. Find volume. The first question, right? That 8 that was asked in some exam. I think it is JEE exam only. This is what I was telling you last time. Now you need to understand, when you say 8 means you use such a bad scale, that is the reason Serum Takers gives you very bad answers. That's the thing which I wrote in the beginning. To use SF, make sure you're using pretty good instruments. Get the answer for this. Now look at this thing. We know volume is nothing but length into length into length. So in the first case, we would be 8 centimeter into 8 centimeter into 8 centimeter. This is 512 centimeter cube. But the problem is this thing has only one SF. So we have to report the answer as 5 into 10 square centimeter cube, 100. That's the problem. Cube ray god, not surface area. What about the second guy? Second one is 8.0 centimeter. 8.0, 8.0. This is 512 only, but when you round it off, it becomes 5.1 into 10 square. So basically you'll say 510. This thing, the volume will be 512. Hope you're getting the answer. So if you just tell me length of the cube is 8, I will say the volume is 500. And that is what they expect in the exam also. They'll say length of the cube is 8 centimeters. So what is the rule? So this is what I was saying. 8.00 is a very good measurement. That's why you got pretty decent answer. Matlab, it came what it's supposed to be. But when you use bad instruments and you use bad readings like this, 8 centimeters is a very bad reading. Meaning, just understand, when you say 8 centimeter, what am I assuming? The person who used the scale is using a scale like this, isn't it? Isn't this a bad reading? Meaning the value can be anywhere between 8.5 to 7.5. It's a bad scale. It's a very bad scale. Clear with this? Centimeter volume, na re? It's a cube, right? I wrote centimeter square here. I wrote cube only, no? Okay, in B, it's a cube only. All got this? So those are some of the rules. So next class, when we catch up on Thursday, we'll continue from here. We will do 1 or 2 more examples on this, and then we'll start off with errors. That would be an important one, but that is also easy and it is not tough. So mostly we should try to wrap up, errors on Thursday, and after that, next week we will start off with laws of motion. Okay, so with this we'll wrap up for the day, and do resolve the paper. So on Thursday we'll discuss the paper ka doubts also. But how was the exam this time? Is it tough? So do resolve the paper, see what went wrong.